Here we have a problem on exponential equation. Okay, let's go to the question. 7 to the x to the power negative 4 to the x to the power equals to 33. In the equation above, find a possible value of x. That is, we have to solve for x in the given exponential equation. Okay, now let me take the given equation as it is. That is 7 to the x to the power negative 4 to the x to the power equals to 33. Okay, now in my first step, what I'm going to do is I'm going to divide this exponent x by 2, and to adjust the division of 2, I multiply this one by 2. Okay, even if I simplify this one, it is equal to the original stuff x over here, because this 2 will cancel, it is equal to x. Okay, now let me do the same thing at the exponent over here. That is, I divide this x by 2 and multiply it by 2 equals to 33. Okay, now let me consider the power of a power rule in exponent. That is a to the mth power whole to the power of n equals to what? Okay, here we have base a and exponent m, and for this complete stuff we have the exponent n. Whenever we have two exponents like this, what we can do is we can multiply the two exponents, then I'm getting a to the power of m times n. Okay, now we can consider the same rule in the reverse way. That is, let me consider the stuff on the right side. We have base a and we have two values are multiplied at the exponent. Whenever two values are multiplied at the exponent, one of these two values can be taken as the exponent for this base a, and the other value should be taken as the exponent for the complete stuff. For example, if I take the first value m as the exponent for this base a, I am getting a to the mth power, and the other value n should be taken as the exponent for this complete stuff. Okay, now we can do the same thing in our problem. Here two values are multiplied at the exponent. So now what we can do is we can take the first value x over 2 as the exponent for this base 7. Then I'm getting 7 to the power of x over 2. And the second value 2 can be taken as the exponent for this complete stuff. Let me do the same thing for this one. Then I'm getting 4 to the power of x over 2 all to the power of 2 equals to 33. Okay, now let me consider an important identity in algebra, that is a square negative b square. Actually, it's called difference of two squares. Whenever we have difference of two squares, it can be written in factor form, that is a positive b times a negative b. Okay, the expression we have on the left side over here is exactly in this form. At the place of a, we have 7 to the power of x over 2. At the place of b, we have 4 to the power of x over 2. Okay, now what we can do is we can write this one in factor form like this one. Okay, so for that we have to write a positive b. For a, we have 7 to the power of x over 2. For b, we have 4 to the power of x over 2. Actually, I have written this one for a positive b. Now I have to write another factor, that's for a negative b. Then I am getting 7 to the power of x over 2 negative 4 to the power of x over 2 equals to 33. Okay, here on the left side, we have a product of two quantities. Okay, since we have a product of two quantities on the left side, on the right side also we can try to write this 33 as a product of two numbers. I think there are two possible ways to write this 33 as a product of two numbers. One is we can write 33 times 1, and the other one is 11 times 3. Because when I multiply 33 and 1, I am getting 33. When I multiply this 11 and 3, I am getting 33. Okay, here the product of these two binomials can be equated to either this one or this one. Okay, now let me equate the product of two binomials to this one. In that case, I am getting 7 to the power of x over 2 positive 4 to the power of x over 2 times 7 to the power of x over 2 negative 4 to the power of x over 2 equals to 33 times 1. I just assume this is equivalent to this, but both of them are equal to 33. So now I take this one equal to this. Okay, here let's consider 7 to the power of x over 2. Since the base 7 over here is a positive value, whatever value we have for x at the exponent, always this is positive. And for the same reason, this one is also positive. Here we are adding two positive values, and here we find the difference of two positive values. Okay, so in these two binomials, which one can be bigger and which one can be smaller? So here in the first one, we have addition of two positive values. Here in the second one, we have the difference of two positive values. Always the addition of two positive values will be bigger than the difference of the two same positive values. So this one has to be bigger and this one has to be smaller. On the right side also, we have a bigger number. 33 is multiplied by the smaller number 1. So we have the pattern, the same pattern on both sides. So a bigger number is multiplied by a smaller number, a bigger number is multiplied by the smaller number. So now what we can do is we can equate the bigger number on the left side to the bigger number on the right side. In that case, I am getting 7 to the power of x over 2 positive 4 to the power of x over 2 equals to 33. Now we can equate the smaller number to smaller number. Then I'm getting 7 to the power of x over 2, negative 4 to the power of x over 2 equals to 1. Okay, now what we can do is we can add these two equations. When I add these two equations, this positive 4 to the power of x over 2, negative 4 to the power of x over 2 will cancel out. Okay, here we add two like terms. That is, just assume this is a and this is a. When I add a and a, I'll be getting 2a. But instead of a, we have 7 to the power of x over 2. Let me write this over here. And also on the right side, when I add 33 and 1, I'm getting 34. Okay, now let me divide both sides by 2. When I do so, this 2 will cancel out. I'm getting 7 to the power of x over 2 equals to 34 divided by 2 is 7. Okay, I got 7 to the power of x over 2 equals to 17. Now, so we must be able to write this 17 as the power of 7. So when I write this 17 as a power of 7, that is something like 7 to the power of something. What we can do is we can equate the exponents, because here the base 7 on the right side also, when I get the base 7, we can equate the exponents. Whenever two terms are equal with the same base, we can equate the exponents. But is it possible to write this 17 as a power of 7? No, 17 is not a power of 7. So in that case, we may have to convert this equation to logarithmic form and solve for x. So I think it's a little complicated. So better we can try this one. So far we have equated the product of two binomials to 33 times 1. Okay, now let's try the other way. That is, it can be equated to the other stuff 11 times 3 and see whether we can get the value of x easily. So in that case, what we have to do is we have to replace the stuff on the right side over here by 11 times 3. So the same thing, a bigger value multiplied by smaller value. Here also the same thing, bigger value multiplied by smaller value. So now we can equate the bigger values and the smaller values. In that case, I'm getting 7 to the power of x over 2 positive, 4 to the power of x over 2 equals to 11. Now let's take the smaller value, that is the difference of the two numbers, 7 to the power of x over 2. Negative 4 to the power of x over 2 equals to the smaller value on the right side is 3. Now let's add these two equations. When I do so, the positive value and negative value will cancel out. When I combine these two like terms, I'm getting 2 times 7 to the power of x over 2. On the right side, when I add 11 and 3, I'm getting 14. Okay, now let me divide both sides of the equation by 2. When I do so, this 2 will cancel out. Then I'm getting 7 to the power of x over 2 on the left side. When I divide 14 by 2, I'm getting 7. Now we have a power of 7 on the right side we have over here. That is, this 7 can be written as 7 to the first power. If there is no exponent for a number, we can assume 1 as an exponent. So this is a power of 7. Okay, here two terms are equal with the same base. That is, the base on the left side is 7, the base on the right side is also 7. So whenever two terms are equal with the same base, what we can do is we can equate the exponents. Okay, when I equate the exponents, I am getting x over 2 equals to 1. Now to solve for x, we have to get rid of the denominator 2 over here. For that, we have to multiply both sides of this equation by 2. When I do so, this 2 will cancel out. Then I'm getting x on the left side. On the right side, 1 times 2 is 2. Okay, in the given equation, I got a possible value for x, that is x equals to 2.